AT viewers of the ROBOTY channel have definitely used and ground something with a disc like this, whether in their garden, garage, or at home. And probably just like me, you've wondered how these discs are made. In today's episode on the ROBOTY channel, we'll answer that question. We'll show the entire production process from the raw abrasive material to the finished product. So what do you say? Let's get to work.
By the way, the press itself weighs 84 tons.
What's the machine's total value?
Over €1 million. Here, the temperatures are already very high, up to 1,250 degrees. It's no secret that we also test competitors' abrasive wheels. As for our shipping, we send about 30 to 40 pallets a day.
With me is Jarek, today's episode expert. Welcome. Hello. We are in the heart of production. What is produced here? What are your products?
Wojtek, you have a finished product here because this is a cutting wheel, 125 by 1. Here we only see grinding wheels used with power tools for grinding and cutting various materials. Well, generally the range of products is very wide because these are items, attention, from 8 up to almost 1,200, so products from a few grams up to over 300 kg when it comes to weight. I would be happy to take you to the production department and show you from the very beginning how such products are made. The production process starts with the mixing process. Here, the operator is preparing a printout of the mixing card. The batch sheet is a set of information about which components to prepare, in what quantities to prepare them, and how to properly carry out the mixing process. Here we have a 2-bowl mixer. This is a mixer that can prepare batches of up to 200 kilos at a time. We have a lot of these mixers because there are about 5 2-bowl mixers at the moment, plus there are also single-bowl mixers. The preparation time for a mixture determines how many batches can be made in a shift. The mixer operator's job is to first prepare the composition of the grains. Of course, he weighs these grain compositions properly and pours them into the first bowl. And here we can see the end of the first mixing process. A plasticizer is added to the grain composition. Here we can see that all the components are in the production storage at the top. We deliver the grain mixture through these hoses. We feed in the liquid resin. We add it to the grain mixture. And to put it very simply, each grain has to be nicely coated with this liquid resin. Then from this first stage, we transfer it for the second mixing stage. And here the mixer will add powdered components. There are powdered resins and various fillers.
And the abrasive grains that we see on sanding discs or on grinding wheels are made from natural or synthetic materials. What is an abrasive grain?
They are minerals, just processed, of course, right? The basic ones are aluminum oxide and silicon carbide. We imagine the abrasive grain like a grain of sand, but these are often grit sizes that can vary dramatically, and some can be very coarse. Here, let's say we start with grit sizes 10, 12, and 14, and we even go all the way up to 1,000. And now, so that the viewer also understands what this grit size means, let's say I choose 400 now. If this grain were to pass through the mesh, there would have to be that many holes in a single inch of the sieve. So these are already very fine granulations. At this point, after the mixing process, the ready mixture will be poured onto the sieve, it will be sifted, and then it goes to the conditioning process. What you see at the top, those large pipes, are air handling systems. In our industry, the quality of the abrasive mixture is highly dependent on proper climate conditions. That's why we have powerful air handling systems. After the mixing process, the mixtures need to be conditioned, which means we transport them to a room where they are left to rest. This conditioning process takes from about 4 to 36 hours. We often say it's like the maturing of the mixture. There are liquid components and powdered components in there. There needs to be enough time for the mixture to properly mature and have the right processing properties so that it can be used.
I'm watching this production process and I'm really impressed that you can say that from such a loose powder, under pressure, we get these stones that later grind down thick metal and other materials. What pressure is used? What are these machines? And how are grinding stones made from this powder?
After the abrasive mixture has been conditioned, it goes to the forming departments, to the forming sections. And here we are in the simplest section, the manual press department. We form abrasive tools, that is, we press them on hydraulic presses. We give the product its initial hardness by changing its volume, that is, we pour a portion into a mold that has the proper geometric dimensions. Then, by applying pressure, by achieving the right pressure, we change its volume and obtain the proper density of the product. So, such a pressed product has what is called initial hardness. The binder here is resin, in this case the resin's used in the mixing process. Then these products go through a thermal process, and that's when they achieve their final hardness. Most of the products around here that we see are for the railway industry. This is a sector that is currently developing rapidly around the world. A truck like this, which reprofiles the rail, moves slowly, and each of these rails is reprofiled.
I've seen this in short social media clips, but maybe someone watching works at a company like this or grinds tracks with these stones so we could feature it on the Do ROBOTY channel someday. So feel free to write either in the comments or by email if you do this kind of work, because I'd love to see your materials that are already working in real life.
Besides that, there are also some slightly larger products, 250, which are used for regenerating railway switches. And we also have some very large products, but these are bonded, ceramic bonded products, 600, 750, and 800, which already have their finished profile around the circumference. The rails move just like a train wheel, only of course at much higher speeds, and they also give the rail its proper profile. After the forming process, where we achieve the initial hardness, now we need to carry out thermal hardening processes. Batch ovens are chamber-type furnaces. The heating times range from, let's say, 24 up to 36 hours. It works like this. We transport such a rack inside the chamber. The temperature inside is raised. It's also a stepwise process of raising the temperature, plus at the very end, the actual heating. After this heating time, which is on average about 30 hours, we then cool these products for 30 hours and reload the given chamber with a new batch. Finally, after the thermal hardening process, we have the proper final hardness of the abrasive tool. These are temperatures in the range between 150 and 180 degrees, so not very high.
So this paper here won't burn or scorch?
No, it will just change its color. This paper only protects the products so that they keep their shape and dimensions. However, we'll also show the hardening process, in this case firing ceramic products, where the temperatures reach up to 1,250 degrees.
I see a lot of these metal plates around the plant. What are they for?
These are so-called separators, which are spacers used for stacking our products for the thermal process, that is, for thermal hardening. After forming, we have to stack the products in such a way that they don't change their geometric properties or dimensions or lose their flatness in the bakelizers. Here we have a fully automatic press, a rotary press specifically for producing the 125 by 1. The operator refills the external magazines, meaning he refills the abrasive mixture and the fiberglass mesh. However, all the tasks inside, meaning the feeding of these components, are done automatically. The rotary press has a daily output of over 5,000 pieces in 8 hours. So in 24 hours, this one press produces over 15,000 grinding wheels. This is the completed stack for the thermal process.
They're not quite even, which is why we use these spacers, right?
The grinding wheel is flat because all its dimensions are correct, but it's still flexible because for now it only has its initial hardness. But after the thermal process, it becomes a rigid product. The fiberglass mesh is used to reinforce the grinding wheel and increases its dynamic strength.
So we've come back to the place where we started this episode.
Because after thermal hardening, the products come here for statistical inspection, meaning all orders undergo inspection checks. We examine the geometry, we check the balance of the product, we also check the weight, but we also have to verify compliance with the standard in terms of critical speed. She is currently mounting the product on the burst tester, which is a device for testing dynamic strength. In this case, she is mounting a 125x-1 millimeter product. The test speed, which is the standard that this product must meet, and after testing at this speed the product can be sold, is 13,500. On the other hand, the critical speed is the speed below which the product cannot break. This is a destructive test because we will break the product and must reach a rotational speed above its specified critical speed according to the standard during the process. In this case, we need to achieve at least 21,150 revolutions per minute. The lady will conduct such a test and cause it to break. Here, there will be rupture detection, meaning we will get a printout with the speed at which the product broke. We need to protect ourselves. Thank you. In this case, we achieved 28,609 revolutions, and
You said
21,150. 21,150 is the critical speed above which the product can actually break apart, so everything went well. Everything went well.
And is this for, let's say, every batch, or how often?
We test every batch and check that it meets the critical speed requirement.
We've already shown products for the railway industry. Here are more products as well. Abrasive ones, both small and large, pink and blue. What other industries use your products?
There are, of course, a lot of these industries, but if you're asking about the more interesting ones, then listen to this. These are grinding wheels for medical needles. Generally, we distinguish between two types of grinding wheels for the medical needle industry. The first are cutting wheels. What does it look like in practice? We have these tubes, which later become medical needles. These tubes are gathered into bundles, into packs. And now, pay attention. In this bundle, there are from several hundred to several thousand of these tubes. These grinding wheels are used only for cutting, but then the next operation is the grinding process.
So their sharpness helped them penetrate well, right?
Yes, that way they could penetrate easily.
Other than medicine and those needles,
What else is interesting? Well, for example, we have a grinding wheel, the so-called mustard wheel. Actually, it's a grinding wheel for grinding mustard seeds, or more precisely, for mustard pulp. So we put in mustard seeds. And a grinder that uses our grinding wheels for this purpose can process several hundred kilograms of mustard pulp in an hour.
So food, medical, railway industries, I won't ask about the industries, but about the number of different products you make here. From the smallest to the largest, what does your product range look like?
Nearly 10,000 active applications. That means the ones we have running, because customers order different products. Not every product is made every week. Some are made more often. 10,000 different ones. Yes, 10,000 different ones, like I said, from 8 millimeters up to almost 1,200.
To make a product, you need high-quality raw materials, which usually require testing. Now we're in the lab. Various colors and graduated cylinders. What's happening here?
We review all the physicochemical parameters we set when choosing suppliers. That's what we're checking. Density, particle size, chemical composition, whatever we can think of, our ladies here are able to test it.
I also saw that there's a microscope, and that this material is examined under the microscope as well. Yes.
We always check it very carefully.
When the powder is scattered, you can't see the mineral's quality, but here it looks almost like emeralds and diamonds.
The color comes from the chemical composition. We can measure their size, and in this way we check if the parameters match our orders.
And what kind of material is this?
This is generally electrocorundum, right? And depending on which element is used there,
It can contain chromium, it can have different levels of purity, it comes in different colors, white, brown.
Up close, it looks beautiful, something you don't have in this bag. These are fractions of a millimeter and shimmer beautifully.
The next forming station, a heavy press, 2,000 tons of pressure, that's what we call it. The press itself, by the way, weighs 84 tons, and we also have a 3-meter foundation going down. A very innovative press. It forms products from 400, actually from 300 to 1,150 exactly. That's the largest forming dimension. The press operates with a technology that achieves very high surface parallelism. Despite this large diameter, we are able to press products that have an external surface parallelism of 0.05 millimeter. The operations are partly automatic, partly manual, with individual steps. Here we currently have automatic weighing. The mixture is placed on an electronic scale and then fed into the belt feeder. And in a moment, Wojtek, you'll see how this mixture goes into the forming ring, into our mold. Here's an interesting fact. The heaviest product we've ever formed weighs, get this, 326 kilograms. These products are very heavy, so we use feeders for the grinding wheels and handling components like the forming plates. Take a look.
How much is this machine worth?
Over €1 million. The industry is very specialized and very specific. That's why most of the equipment used here is built specifically for this industry. Even the processing machines, meaning the CNC machines, are actually dedicated to our industry. These are grinders for processing basically any surface. In this case, CNC machines use diamond tools to grind our conventional grinding wheels. Listen, they're either ceramic or organic. Here we have a grinding wheel with a thread profile mounted for machining gear wheels.
I also wanted to ask, What do you use to grind grinding wheel materials? They're already extremely hard to grind themselves, so what do we use to grind them? It's like the same paradox of how you glue Teflon since nothing sticks to it, right?
Yes, exactly, but in that case we use super hard tools, meaning tools with diamond grains or sometimes with very hard borazon grains, but in our case diamond, okay?
Behind us in the background are modern machines, and with us is the current management board of the company. Welcome.
Hi, Anya, Andra, hi.
Robert, Andri.
A warm welcome. First question, are you the ones who created such a beautiful, huge Polish company? How did it happen? No.
We didn't create it, our father did. Also Robert Andri, but senior. Next year we will celebrate 40 years since then. We, as the management board, have been managing this company for 5 years. Our father worked at a state-owned company at that time, which also produced abrasive products. Simply put, at some point he decided it was time to try his own thing, and he started this business, you could say, from scratch, from that proverbial garage.
How does the development of this company look now, under your leadership? Have you also put your fresh young energy into making the company grow even more, or are you rather following the path set by your father?
Our first guiding principle is, just like our dad always explained to us, to keep developing all the time. And that's our value, the one we always follow now that we're managing the company on our own. We try to run the company in a modern way, automate it, but also keep looking for new opportunities. Look for those niches in the market where we can grow more, and of course, look for new markets.
Sales. Despite this automation, there are still quite a lot of employees.
Yes, because that's crucial for us, right? This is a family business, and we always emphasize that it's a fully family-owned company with Polish owners. We have people with us who have been working here for 30 years or even more. And together with my dad, they helped build this company. And now, even with the succession, where our approach is definitely a bit different, they've still adapted to it and continue to develop the company with us. That's really great, isn't it?
And here we ask all the viewers for comments and likes, because people often write that many companies are supposedly Polish but not really Polish, or whether they have Polish or other capital or are managed by someone else. And here you have to admit it and like this video precisely because this Polish identity has remained. Thank you very much, and I wish you lots of success in your continued growth. And now let's move on.
Earlier we showed the thermal processes, meaning the hardening of resin-bonded products. However, ceramic products need to be fired. And here the temperatures are already very high, up to 1,250 degrees. The whole cycle takes almost 100 hours. Right now we have 5 such ceramic kilns. In this case, as you can see, there is no steel, no aluminum, because the temperatures at which we carry out this process, that is 1,250 degrees, would simply cause all the steel or aluminum separators to melt. And in this case, we place the products on such refractory elements, in this case, ceramic plates. Each time after loading a ceramic cart like this, both of these carts have to be transported into the furnace. The furnace is well insulated. We have tracks and transfer cars. We put the carts loaded like this directly into the furnace, and then we start the process. After 100 hours, the product has its final hardness. It is then removed from the cart. And these products go through more processing, specifically abrasive processing. Here, we generally grind our products. We have demonstrated the full abrasive tool production process. But Wojtek, before this product goes to the customer, we still have to check how it performs in actual use. The element has been weighed. The grinding wheel is mounted on the angle grinder. He will be grinding. We will measure the grinding time, then we will measure how much weight we lost on the part. And we will calculate the proper indicators.
Let's get to work. It's working. Judging by the look and feel, it's grinding well.
Oh, nice. And then we measure the time. We'll weigh it to see how much the grinding wheel wore down, and that's basically it, right? Still, it's a performance testing lab. So that these activities are always repeatable. So that all the parameters and all the elements we add here to these performance tests are repeatable. We test on a device that under constant pressure cuts the workpiece in this case, and we directly measure the number of cuts. How many cuts will a given grinding wheel make? Technologists analyze these indicators in order to properly design future production processes.
This disc cuts through it over and over until what point? Until it wears out?
Or whatever we're checking. Yes, until it wears out completely, so it reaches a limit of wear to a diameter at which cutting would no longer occur. This is information that serves as a guideline for us on how to design these products so that the customer is as satisfied with them as possible. It's no secret that we also test our competitors' grinding wheels, and everyone does it. So we mount products that are available on the market to see and make sure that our product is, of course, the best.
We are in the finished goods warehouse, 1,000 square meters, high bay storage racks with a maximum height of 5.5 meters. As for our shipping, we send about 30 to 40 pallets a day. That's about 1,000 per month. You could say all over the world.
All over the world. Soon it'll be shrink wrapped and shipped. 30 more pallets today.
Yes, we have a shipping window right now, so in a moment all the couriers and loading teams will show up here, and all of today's work will soon be loaded onto the trucks.
Do you handle the logistics?
We handle the logistics.
Jarek, I'm taking one package home. I'll test your discs on my own grinder. I have to congratulate you on your vast knowledge about this plant. It's great that the viewers stayed until the very end. They will definitely appreciate your knowledge because I am truly impressed by everything you've told us throughout the whole episode, so thank you very much.
Thank you very much. It was a pleasure for me to present our process. It was nice to show all the viewers how these products are actually made because maybe not everyone realized that it's such a complicated process.
Definitely, when buying such discs in the store, we don't see the whole process from raw material to finished product. Now you'll know how something like this is made, so when you see them in the store, you can confidently buy them, and I'll take one and test it. Please leave a thumbs up, subscribe to the ROBOTY channel, and comment on which other factories I should visit. Thank you.
See you.
Thank you.